I want to show you a few things with collision. So what I have here is a force versus time graph, a velocity time graph for each of two carts that are going to collide with each other. They have springs on them, so they should collide in a way that is close to elastic. We can watch the little video of the collision, right? Something like that. One cart is moving. And what I've done is I've synced up the data collection that I did with the time, and so we can watch that together. So what we see here is that there is a spike of force equal and opposite, corresponding, of course, to notice the impulse. One gets a positive impulse, one gets a negative impulse, about 0.14 Newton seconds. And while that is happening, right, you see that the start of the collision occurs when you're going, the first cart, the bluish green cart, is going the fastest. And then as that goes on, right around the time that they are essentially equal speed, the force starts to diminish. And then at the end of it, they're back to the original. So we can check the speeds. We got 0.518 meters per second and 0.507. There's a little bit of friction as shown by this going down line. So it's not actually a constant velocity. But essentially the velocity swaps. One of them stops and one of them goes. Now we're going to look at a case where where you still have the springs between them, but now the cart doing the hitting is lighter. I've put some extra masses on that yellow cart. You can watch that. And so that causes the light cart to recoil. We can look at what happens when the graphs are played back this way. And what we see is that we've got a big velocity for the greenish cart before it hits. But because it's so light, it has its impulse causes it to change direction. And then the yellow cart moves forward, but not nearly as fast, right? The impulses are still equal and opposite up here if we do our mu integral, right, about 0.2. But the change in velocity for the green cart is pretty dramatic from positive to negative, and the yellow cart goes from rest up to some speed. For the last of the spring collisions, which are close to elastic, we have a heavy mass. Now the mass, as you can see, are on the green cart hitting the light mass. And we can watch that happen, right? And the yellow light mass goes off quite dramatically. So if we sync this up and watch it with the data, you can see that even with a relatively small initial velocity, the green cart, which is heavy, even though, again, they still have the same impulse, right? Equal and opposite impulses. What happens is the green cart with the large mass only slows down a little bit and keeps on going as it goes through, whereas the yellow cart, which is at rest, now moves off quite rapidly, right? We can watch that again to see how it happens. That even a slow speed from the heavy mass causes the light mass to go quite quickly.